Hey guys, all right, now let's take a look at the heart. So this chapter we're focusing on as you can tell by the title, in chapter 16, we're looking at the anatomy of the heart. So we're going to focus on the different parts. Now, you have an entire chapter dedicated to the function of the heart in your textbook, and we're actually going to skip over that, but only because we're going to go into a little bit of detail with the function of the heart in this chapter. So when we're talking about the different chambers of the heart and the different layers of the heart, when we get into that today, I'll talk to you guys about what these things do. So we kind of touch on the things that I want you guys to know in this chapter without having to cover a whole different chapter. It goes into a little bit more detail in chapter 17 than I really want you guys to have to get into. So let's go ahead and let's take a look at this chapter. So taking a look at chapter 16 here. So as you can see, again, it's the anatomy of the heart. Come on, keep going. Okay, there it goes. All right, so in this chapter, we are going to take a look at the location of the heart. We're going to look at the 3 different layers and the covering of the heart. Our heart has all kinds of different protective layers on it, just like a lot of the things that we've discussed already have protective layers. Just like if you remember in the nervous system, we talked about the meninges that cover the brain and the spinal cord, and the heart is very similar. It being a very vital organ as well, our body has designed layers that will protect it. So we'll look at the function of the heart too, as 2 separate pumps, and I'll show you guys what I mean by that. We'll take a look at the 4 chambers and the great vessels of the heart, and so I'll show you these different parts, and I'll have a labeling diagram for you guys in this chapter as well. We'll take a look at the function of the different valves in the heart. There's 4 important valves in there. We'll look at the physiological basis of the heart sounds. So I'll explain to you guys what produces those sounds you hear when you're listening to a heartbeat. The blood flow through the heart will follow the flow as it travels through these different chambers that we'll identify. We'll look at some of the vessels that supply the heart. So we'll talk about some of those major vessels. I've cut this up a little bit so you guys don't have to get into a lot of them, so I'll show you guys what I mean by that. And then I'll explain to you guys what I mean by the heart's conduction system. Okay, so let's take a look at this. So your heart, located between your second and your second rib and your 5th intercostal space, so which is the space between the 5th and the 6th rib. So you can see it is about the size of a fist. If we ball up your fist, that's about how big your heart is, and it is positioned a little bit to the left of the sternum. When you see the terms apex and base, the apex of the heart is the bottom part of the heart that forms that pointed shape at the bottom as it points to the left there. And so you can see that is the lower pointed end of the heart. The base is the upper part. Oftentimes we think of the base and we think of the bottom of something, but the base in the heart is actually the top, because it's the upper, it's the flattened portion up there at the top. The apex is the point of it at the bottom. And the precordium is the anterior chest that's overlying the heart. So if you hear that, it's talking about just the chest portion that sits on top of the heart. I probably won't test you guys on that. The main thing I want you guys to know from this are the terms apex and base. That's what important terms in describing the shape of the heart there. The heart is composed of 3 different layers. So we can see there's a picture of a heart here, and it's got the pericardium on the outside, but then the heart itself, you can see, has some different layers to it. So we have, if we were to cut open this little section here and look at that inner wall of the heart, this is the inner lining of the heart, so blood's rushing past this section. This is just one of our inside chambers. This is the muscular layer of the heart right next to it, and then this is the outermost layer that has another protective coating even outside of that. So the 3 layers of the heart all end in the word cardium. Every layer that we're discussing here ends in the word cardium. So if you hear that, we're talking about layers of the heart. It's the different prefixes that help you to see where these different layers are. So the endocardium is the innermost layer of the heart. So remember, endo meaning inside. Our myocardium is the middle layer of the heart itself, and some people remember the M for myo, not just for middle, but sometimes for muscle, because this is your layer of cardiac muscle that is going to actually provide those heart contractions. That's the myocardium. And then the epicardium right out here, so this kind of what's being pointed out is this blue structure here. This is the epicardium, which will eventually become part of the pericardium. And the pericardium is this kind of brownish structure that you're seeing on the outside here. This is just an added kind of coat around the heart. It itself has 3 different layers. And I'll be honest with you, I'm not going to test you guys on these 3 specific layers of the heart, but I mean, I'm sorry, of the heart. Yes, I do want you guys to know the endocardium, the myocardium, and the epicardium. But the pericardium itself is, like I said, it's like an added coat to the outside. So it's like when I put on this sweater, this is my pericardium. I already have layers, you know, of my skin here, but when I put this on, now the heart has an extra added layer, and that's where the pericardium comes in. And it itself has 3 different layers. The epicardium from the the outside layer of the heart itself is considered part of the pericardium. And then we have the parietal pericardium and fibrous pericardium, which are these just 2 double walls on the outside here. Like I said, I wouldn't worry too much about the specific layers of the pericardium itself, but I do want you guys to be familiar with the fact that pericardium is that added layer on the outside of the heart itself. There is a small space between that the epicardium and the pericardium, and that is called the pericardial space. It does have a little bit of fluid in it that will provide somewhat of a lubrication, that as the heart will beat, it allows that fluid movement there inside of our chest cavity. So that is the layers and coverings on the outside of the heart. So do be familiar with those. So our heart acts as a double pump. It has 2 different circulations. If you can see in this picture here, let me tell you a little bit about what we just talked about with blood in our previous chapter. Remember how I mentioned that blood was our transporter in our body, that it's got to deliver, its job is to deliver oxygen and nutrients to all of our tissues throughout our body. So yes, we do get that oxygen up in the lungs. But instead of it being taken from the lungs and immediately transported to our tissues, everything has to go through the heart first. So what happens is this oxygen is picked up in the lungs, pumped to the heart, and then pumped to the rest of our tissues. Same thing when our tissues produce that waste gas called carbon dioxide. That waste gas must be exhaled in our lungs. So instead of that waste gas being taken right from our body and then immediately to our lungs, it simply just has to go to the heart first. So this oxygen poor blood is going to take this carbon dioxide, first pump it through the heart, and then take it to the lungs. So the way to think about it is, if our blood is kind of like the delivery drivers of this of UPS, the heart is the UPS hub. Everything has to go through there first in order for it to make these deliveries. So that's what I mean by that. So it kind of goes in this kind of figure 8 type fashion, that it goes from the lungs but to the heart first before it can be pumped to the body, and then from the body to the heart first before it can go back up to the lungs. And that's what's happening in this picture that you guys are seeing here. So the heart is kind of a double pump. One side is colored as blue, as you can see, and one color is colored as red. That is because the right side of the heart is dedicated to pumping our oxygen poor blood. This is the blood that is being returned from the body, that has been, we've dropped off the oxygen, and now we need to go back up to the lungs and get more. So it's colored as blue because, again, the hemoglobin is not holding on to oxygen at this time. So even though blood is not blue, it is kind of a bluish, darkish red color, but it's obviously, for easier understanding here, to differentiate between the 2 sides, it's blue versus red. So that's the oxygen poor blood, and that will be pumped then back to the lungs. The blood returning from the lungs, after we've picked up that oxygen in the process of inhaling that oxygen, we now take that blood and pump it to the heart. So the left side of the heart is going to be dedicated to pumping this oxygen-rich blood. So that's what we'll see when we label our heart diagram today. You'll also see these same 2 different colors. So the right heart is for oxygen-poor blood. The left heart is for oxygen-rich blood. And then there are 2 different circulations that happen in the body. So the figure 8 formation that I was just telling you about, you can see that, we've got kind of it looks like an 8. It looks like like I said, it's kind of a figure 8 fashion, where blood must be, taken from the lungs to the heart, then to the tissues, and then from the tissues to the heart, and then to the lungs. So really the circulation that occurs between the lungs and the heart, because of the involvement of that connection between the lungs and the heart, that is called pulmonary circulation. Anything that involves the lungs is oftentimes referred to as pulmonary. We'll talk about a couple different structures on the heart itself. Because of its connection with the lungs, we will refer to that as pulmonary. So for instance, we'll label a pulmonary artery on our heart today, and that is because it's going to the lungs. So that's what that means, that it's the circulation that is, right here between the lungs and the heart. Whereas the connection between the heart and now the rest of the body, that is called systemic circulation. So oftentimes think about that as it involves the rest of our body systems. So it's that oxygen that's being delivered to all of our systems of the body. So that's where systemic circulation comes in. So that's what I mean by the difference between those two. We'll see another picture that looks just like this one that defines a few things, a few of the blood vessels that we'll talk about in the next chapter. All right, so we have different chambers in our heart. We're going to label each and every one of those. We have 4 chambers in our heart. The top chambers are called the atria. Atria is just plural because there's 2 of them. If you're looking at them just singular, there's the right atrium and the left atrium. So we've got the atria on the top, and the bottom 2 chambers are called the ventricles. And again, they're just named according to what side they're on. So there's the right atrium and left atrium at the top, and then there's the right ventricle and left ventricle down at the bottom. So we'll label these on our diagram, and I'll show you what I mean by that. Then we have some major vessels. When I say blood vessels, I'm talking about arteries and veins. Later on in the next video, we're going to talk about the difference between arteries and veins. And I'll discuss with you that arteries are typically those blood vessels that carry blood towards the heart, meaning that this is blood. I'm sorry, arteries, I mixed that up. Arteries are going away from the heart. Remember, A for artery means A for away. So arteries are going away from the heart, whereas veins are the ones that are coming towards the heart. So, when we see these, when I say blood vessels, that's what I'm talking about. But we have on the heart itself, we have some veins and arteries that are really, really important for the role of moving blood through the heart. Specifically, we have some veins and arteries. The vena cavae, or vena cava, if you're looking just one at a time, vena cavae is plural because there's 2 of them on the heart. These are the largest veins on our heart. Veins meaning that they're coming towards the heart. We're gonna label 2 of them, but that's one of the great vessels of the heart that's bringing blood into the heart. Pulmonary veins, so again, vein still coming towards. Pulmonary veins are bringing blood back in from the lungs, but they're bringing blood towards the heart. And then the other 2 are arteries. The pulmonary trunk, which some people will identify as the pulmonary artery, this is taking blood away from the heart towards the lungs. And then the aorta is the largest artery on our heart, and it is taking blood away from the heart as well. This will make more sense when we see it in a picture, but these are the names of your different chambers and your great vessels. So this is the picture that you guys have in your text, and they've labeled everything here for you. And this is going to be very similar to the diagram that you guys have in your review section, your PowerPoints and review section on Brightspace. And we're going to actually walk through that picture. But it's already, pointed this out for you, and it is showing you the direction that blood will flow on each side. Again, it's a double pump, which means that what is happening over here on the right side of the heart, so that's the blue, is also happening at the same time over here on the left side. It's happening simultaneously. It's just the blood on each side is going in different directions. So let's take a look at this diagram that you guys are seeing. It too is going to show you the different sides as blue and red. And then it's also showing the different directions that blood will flow. So we are just going to go in order as we label this diagram. So you can refer back to the picture on the previous PowerPoint, or the one that was on the previous PowerPoint, like I said, is also in your textbook to help you with some of the terms that we're going to walk through here. But just so we're walking through your specific labeling diagram so you know exactly what the answers are to all of these. So we're going to start with the blue side. We're starting over here on the right. You can see down here at the bottom, it's labeled as the right side of the heart, so that helps you with. That's the right. This is, again, it is blue because it is oxygen poor blood being returned back from the tissues. So this is the blood that needs to make its way back to the lungs to go pick up more oxygen. So what's happening in number 1 and number 2? This is, you can see number 1, you can see this arrow up here at the top, and down here at number 2, the arrow down here at the bottom is showing blood that's being brought back into the heart from both the upper body and the lower body. These are those vena cavae. Number 1 specifically is pointing to the one on the top. So here's your directional terms that we talked about day 1. This is your superior vena cava. Whereas number 2 is your inferior vena cava. So don't forget those directional terms. So like I said, the vena cavae are the ones that are the largest veins on the heart that are bringing that blood back towards the heart. They're going to deposit that blood right here into our first chamber. You can see there's 4 chambers. Here's 1, here's 2 over on the right. And over on the left, we're going to see then 1 and then 2. And before I move a little bit further, I do want to point out to you guys, some people look at this picture and go, well, the right and left is backwards. What does that mean? If you remember when we discussed this on day 1, when we were talking about those abdominal pelvic regions, and we were looking at the person who is facing us, and remember we were specifically looking at their right and left side, and that's exactly what's happening here on the heart, that the person whose chest is looking at us right now, this is their heart, so therefore this is the right side of them and this is the left side of them. So even though I know what's my left and my right, it can be kind of confusing, and it's easily done, it's easily mistaken. So make sure we're paying attention and thinking about it that way, that this person, that's their right and left side. All right, so we labeled number 1 as the superior vena cava, number 2 as the inferior vena cava. And like I said, that blood is going right here into the top chamber. We call it again the right atrium. Remember, the atria are at the top, ventricles are on the bottom, and since this is the right side, we're looking at the right atrium. And so here's what happens in a heartbeat. In a heartbeat, we're going to discuss this further as we continue through this chapter, but what happens in a contraction, it's kind of a double contraction, that the top of the heart will squeeze in first, and then the bottom part of the heart will squeeze in that contraction. Like I said, a contraction is a shortening of that muscle, and so the muscle in the wall here of the myocardium kind of squeezes in at the atria first, and then the ventricles. So it's the atria, then the ventricles, atria, then the ventricles. So that's why you're hearing that 2 different sounds. And I'll talk to you guys about what those sounds are, but it's kind of a 2-part heartbeat, and that's because of that. So when the atria walls contract in, so since we're over here number 3, specifically talking about the right atrium, when the walls of that contract in, it's going to force blood down into this bottom chamber. So that's going to be pointed out here in number 5. Before I point out that ventricle, which you guys probably know what that's already labeled as the right ventricle, but what happens is it goes through this doorway right here. This opening is called a valve. You see that you have 4 different valves in your heart, and they all work a very similar way. Valves work like doorways, that they will open to allow things through, but then when they're closed, things cannot go back through. And that's what this is doing, is it's going to open to allow the blood back through. But then in the second part of that contraction, I don't want blood going back into the atrium. Instead, I want blood going where these arrows are going. I want it going this way. So the valve is going to close after this part of the contraction to make sure that blood doesn't go in the opposite direction. And that's this first valve. This first valve is what's called the tricuspid valve. And the reason why it's called the tricuspid, just if you want an easier way to remember that, cusp means flap. So tri means, again, there's 3 of them. So you can see there's 1, 2, 3, if that helps, that all 3 flaps open and then they'll close like a door. So number 4 is the tricuspid valve. And then again, like I said, everything is going to go through that tricuspid valve and down into the right ventricle. The second phase of that contraction is going to now be the ventricles will contract in. So when they squeeze in, blood's going to be forced upward. Since the tricuspid valve is now closed, blood is all going to move in this direction where those arrows are going. So now, again, remember it's going to the lungs. And earlier I said that anything associated with the lungs, you may want to remember the word pulmonary, because pulmonary means, you know, having something to do with the lungs. So what's happening here is blood is first going to go through a valve. Number 6, labeled over here, is the pulmonary valve. And then that will open up and allow that blood to travel through the pulmonary artery. So on number 7, that's the pulmonary artery or the pulmonary trunk. You can call it either or. And so that's the process that blood takes as it goes to the right side. It just, that same, you know, that same process is actually going to happen on the left side. But looking at the right side again, just seeing how that blood will pump through, it goes through the vena cava into the right atrium, through the tricuspid valve and into the right ventricle, and then out through the pulmonary valve, through the pulmonary artery. And now, as you can see by that diagram, it says that this blood is now making its way to the lungs. Up there, it will pick up more oxygen as we're continuously breathing in. Blood returning back from the lungs will now come in here to number 8. So this is the blood that is coming from the lungs that has picked up oxygen. So we have oxygen-rich blood, and that's why we're seeing this red color now. That hemoglobin is carrying that oxygen, and it's giving it that rich red color. So number 8, since it's coming from the lungs but coming back towards the heart, remember veins are what are going to bring blood towards the heart. So these are the pulmonary veins. Number 8 are the pulmonary veins. You can see that there's some over on this side as well, because it's coming in from the lungs. So think pulmonary because of the lungs, and then veins because it's bringing back towards the heart. So those veins are going to deposit that blood into the top chamber, just like it did over on the right side, but now just over on the left side. So we're seeing that being pumped into the left atrium now. So number 9 is the left atrium. And so again, this is happening simultaneously, but very similar to what happened there. When the top chambers close in, those atrial walls will contract in, blood's forced down into the ventricles, but first through a doorway, a valve. Over here on the left side of the heart, we only have 2 flaps. So a lot of times people think of this, since it's the opposite of the tricuspid, this is now the bicuspid. Number 10 actually has 2 names. Some people refer to this as the bicuspid valve, and some people call it the mitral valve. I'm going to go back and see what your book referred to it as. Let's see. Looks like your book is not pointing that out. I'm sure there's another picture in your book that's pointing out the valves. And we'll look at that later in the PowerPoint too. But that one is either or. It's called the mitral, or M-I-T-R-A-L, or bicuspid. B-I-C-U-S-P-I-D, bicuspid, opposite of tricuspid. So again, that's forcing that blood down into that bottom chamber. Number 11 is now the left ventricle. So that blood was able to go through that bicuspid valve and now make its way down into the left ventricle. The second phase of that contraction is for those ventricle walls to contract in. So since the bicuspid valve is now closed, blood is going to go up through this artery. So first going through the valve at the artery. Number 12 is pointing to the aortic valve. And it is named because it is the valve in front of the aorta, number 13. All right, so again, very similar process to what we saw on the right side of the heart. Blood was coming in through the pulmonary arteries, pulmonary veins at number 8. I apologize for that. At number 8, the pulmonary veins, bringing that blood right into the left atrium, then being pumped through the bicuspid valve into the left ventricle. From there, it made its way through the aortic valve and up through the aorta. And like I said, this process happens simultaneously, and it's happening on both the left and the right side at the same time. Okay. So our heart valves, as I mentioned, here's what we had labeled. Number 4 was a tricuspid. It is between the right atrium and the ventricle. And the bicuspid, as I mentioned, also referred to as the mitral, is between the left atrium and the left ventricle. These are oftentimes referred to as atrioventricular, or commonly referred to as AV valves, for short, because they're between the atria and the ventricles. So that's why these valves are referred to that way. So our AV valves are those two. All right. And then these are referred to as the semilunar valves. These are the valves that are in front of those arteries. The pulmonic valve, or again, we called it the pulmonary valve. Either one is fine. But the pulmonic valve is the one that's between the right ventricle and the pulmonary artery. That was, again, that's the side where we're getting that oxygen poor blood to the lungs. And then the aortic valve, named because of the fact that it's on the aorta, it is between the left ventricle and the aorta. So those are our 4 different valves, and we labeled those on our diagram there. All right, so where do those heart sounds come from? Those valves that we just talked about, when they open and close, they produce a sound with every closure. So that lubbed up sound that we continuously hear, that is what we are hearing. A murmur is something when a doctor is listening to your heart, listening to, as you breathe deeply, that doctor is listening with the stethoscope and listening to the sounds. Those sounds, if they are producing an abnormal sound, that's what's referred to as a heart murmur. So if you ever hear the word murmur, that's what that is. So these sounds can be divided into S1, S2 as your different sounds. What happens is, as I mentioned, the heartbeat happens in a 2-part beat. In fact, you're going to see the words systole and diastole as you go throughout the chapter. The term systole means contraction. So the atria is in a systole first. It goes in, that means it's in a contraction. While at that same time, while that's in a systole, the ventricles are in a diastole, the relaxation phase of the heartbeat. And then they trade. What happens is then the ventricles go into systole or a contraction. And then alternatively, then the atrial walls will be relaxed or in a diastole. So they trade off. When the atrial walls contract, remember what happens is blood will be forced down through the tricuspid valve on the right side of the heart, and then through the bicuspid valve on the left side of the heart. Well, then what happens is that means those AV valves will close at the same time, and that produces your first sound that you hear. I actually have a couple of videos, but I know one of them for sure that I'll post as a link in your review section, that has these sounds that you'll be able to hear and see the closure of those valves as you go through the video. It just simply walks through the blood flow of the flow through the heart, and it'll show you those sounds being produced as well. But that's what the first sound is. So then the second phase of that contraction, remember, is the ventricle walls will be in a systole or a contraction, and will force that blood up through those different arteries. So through the pulmonic valve on the pulmonary artery side, so from the right side, and then on the left side, the aortic valve, the blood will flow through, coming from those ventricles. So they will then close at the exact same time. Remember, those were called the semilunar valves. So the closure of the semilunar valves produces that second sound. So that's what we're hearing. As that blood is continuously flowing, we're actually hearing the sound of those valves closing. All right. So again, the direction that blood flows through the heart, we really have kind of already been over that, but it flows into the right atrium from the vena cava, will go through the tricuspid valve and into the right ventricle. When the right ventricle contracts, it will flow through the pulmonic valve and into the pulmonary artery. From there, it will make its way into the lungs. The lungs, we'll talk about capillaries a little bit later, but within the lungs, we have right and left pulmonary capillaries, which is where carbon dioxide will be dropped off and oxygen will be picked up. Our capillaries, when we talk about that in the next chapter, those blood vessels are what's called the exchange vessels. And so that exchange of carbon dioxide and oxygen will take place. And then once that blood picks up that oxygen, it now is going to make its way back towards the heart, where it will go towards those 4 different pulmonary veins. From those veins, it will go into the left atrium. As the left atrium contracts in, it forces that blood through the bicuspid valve and into the left ventricle. As the ventricle contracts, it will push that blood through the aortic valve and then up to the aorta. So this is something that, also is important with our hearts, that blood flow can actually increase up to 4 to 5 times during exertion. So during exercise. So that flow can, again, with exercise, you're exerting more, your heart is beating faster, so it can cause the extensive flow to take place. So flow is greatest during a myocardial relaxation. All right. With disorders of our heart, ischemia or diminished blood flow and oxygen deprivation is what that particular term means. If we're not getting adequate blood flow to the heart, that's where that comes in, and it can cause a lot of issues. Angina is chest pain. So if anybody experiences any angina, that's what they mean. They're experiencing some type of pain. In a complete blockage of oxygen, ischemia is just a diminished blood flow and oxygen, deprived. In a complete blockage, sometimes that can cause the heart to not receive any oxygen that it needs, and therefore it goes under attack. And so that's what a myocardial infarction is. If you've ever heard of an MI, we commonly know this as a heart attack, but that's the more official term for a heart attack, is a myocardial infarction. Remember, your myocardium is the muscular layer, and so it will cause that to malfunction, and that could be obviously devastating. So these are a couple different tests that can test our heart functioning. I meant to take these off. You all don't need to worry about those diagnostic tests. Good to maybe be familiar with as nurses, it's something that you may come across, but you all don't need to worry about that for me. Okay. All right, so that's, different disorders with the heart. The other thing I want to mention to you guys with the heart is what's called the cardiac conduction system. Your cardiac conduction system, if you remember when we talked about the brain in our previous class, last week we discussed the nervous system and how the nervous system is pretty much in charge of every function in our body, that our brain is responsible for seeing things, hearing things, for how we walk, how we balance ourselves. I mean, just everything. It is also responsible for how our heart beats. And that's where this comes in. This is the process that the brain connecting to the heart by sending messages to the heart. This is the flow that impulse will take through the heart. It starts at what's called the SA node, or sinoatrial node, which is your heart's pacemaker. That will set the pace for how the heart is going to beat. It will send a message on either side of the heart to what's called the AV node. AV, think AV like the AV valve, so we know it's over, there's a node between the atrium and the ventricle over on the right side. And we'll also send a signal over to the left atrium, which will cause the atria to beat. Then it sends a message to what's called the bundle of His and then the Purkinje fibers. Let's make sense of this. Here's a picture to show you this. So as the brain is sending its electrical impulse down to the heart to tell it what it needs to do, it starts here at the sinoatrial node, what we will again commonly refer to as our heart's pacemaker, because it sets the pace of our heartbeat. That impulse will then travel through these nerves and then go to the AV node over here on the right side, and then also sending a signal over here to the left atrium to start the contracting of the walls of the atria. From there, that impulse will make its way through to the bundle of His, which is right here. You can see this little node. And that will send an impulse then through the left and right bundle of His. So that just simply means the branches of this nerve conduction that's taking place here. And then down to the specific fibers that extend off of that bundle of His. So there's the Purkinje fibers that come off of that. And that sends a signal to the muscular wall here in the ventricles to cause that to contract. So this is just the series. So just along with what we talked about last week with how our nervous system is kind of like our series of wires, these are the wires of our heart. This is what we're looking at here, is just the wiring system of our heart. So where it starts and how it travels, that impulse will travel and send that message to tell our heart to contract in the walls of the atria and then contract the walls of the ventricles. So I would definitely be familiar with what the conduction system is, and definitely know that our pacemaker is our SA node, and that's where that pace will then start. All right, so that just kind of shows you exactly what I was telling you, that the SA node is going to originate that cardiac impulse. The SA node, again, is your pacemaker of your heart. That cardiac impulse spreads to the AV node in the left atria, and then the reaction would be the atria walls will contract. The AV node then slows that cardiac impulse and sends it to the bundle of His, and the bundle of His will send the cardiac impulse to those Purkinje fibers throughout the ventricles, and the response would be that the ventricles will then contract. So just like I was showing you guys in that picture, that's how your heart's wiring system works. And how we measure that, and the only thing I want you guys to know from this is that this is how we measure our heart's conduction system. We have what's called an electrocardiogram. The electrocardiogram, and well, I guess you guys don't have, some people have different classes on this, but you guys just will probably see this in some of your specific nursing classes. So right now you guys don't need to worry about the P wave versus the QRS and the T wave, but it just shows the process of, you know, these contractions taking place and how that signal is being sent. That's what an ECG will do. So just know that that's how we measure our heart's conduction system, is through an ECG. All right, guys. So that is the end of chapter 16. So the main focus in that chapter is, again, be familiar with the anatomy of the heart, so the different parts and the different layers. And again, we talked about how blood flows through the heart, and that's important to be familiar with as well. All right, guys, you all be sure to let me know if you have any questions.